directly I went to the topic. So our first topic is probability, sir. In this probability, before you studying this probability, the most important thing is you should learn the permutations and combinations. I think everyone know about that permutations and combinations. Just an introduction on permutation and combination. I entered into the topic probability and permutation means just arrangement. Okay, the arrangement of n decimal things taken out at a time. The arrangement of, observe here, Nana. The arrangement of n dissimilar things, taken smaller at a time. Taken smaller at a time. In this, we have three cases. And first one, without repetition, and second one with repetition, and third one is at least one repetition. And first one is without repetition. Without repetition. The formula is NPR. And second one is with repetition. You just remember these three formulas. With repetition, the formula is n power r. And this is 1 function. Already in 1 function, you may study this one. N of b whole power n of a. With repetition, our formula is n power r and d. And third one, at least one repetition. And third one is at least one repetition. At least one repetition is equal to n power r minus npr. Total repetitions will come on with repetition case. Therefore, at least one repetition is equal to n power r minus npr. And these are basic concept and basic concept in the permutations. Okay, na? Right. The arrangement of n decimal things taken are at a time is when without repetition, npr. With repetition, n power r. At least one repetition, n power r minus npr. While we are doing in probability questions, the favorable cases will come under these three formulas mostly. First one by using permutations with the function. Without repetition, npr. With repetition, n power r. At least one repetition, n power r minus npr. Okay. You know how to solve this npr? NPR, for example, I am taking 5p3. NPR formula. NPR is equal to n factorial by n minus r factorial. The value of 5p3, for example, 5p3 is equal to 5 factorial by 5 minus 3 factorial. And 5 minus 3, which is equal to 2 factorial. Observe here, the value of 5 factorial, students. 5 factorial, that is 5 into 4 into 3 into 2 into 1. By denominator 5 minus 3, 2 into 1. And this 2 into 1 cancel automatically. 5 into 4 into 3. You directly write down 5p3 is there. Just multiply 3 consecutive numbers which begin with 3 consecutive natural numbers which begin with 5 in decreasing mode. That is 5 into 4 into 3. For example, 8p3 is there. Or 8p4 is there. Write down multiplication of 3 consecutive and decreasing method. 8 into 7 into 6 into 5. Like that, we can solve NPR. N power r general formula. Number of 1 function. N of b whole power n of n. And at least one repetition. Combination of this, that is n power r minus NPR. Total permutations minus 1. That is equal. Okay, Nana? And next one here we have circular permutation. The number of arrangement of n decimal things taken are at a time. First one. And second case, circular permutation. Circular permutation formula. If we arrange the objects in a circle, around a circle, then that is said to be circular permutation. For example, like this. If we arrange the objects around a circle is said to be circular permutation. For example, here we taken n objects. In circular permutation, we should fix one. Okay. For example, in the circular permutation, we don't know what is first one and what is last one. you just fix first one. For example, in this n, you just fix one. Remaining, how many? For example, already n, one completed means remaining n minus 1. N minus 1. Therefore, the number of circular permutations are the number of circular permutations. The number of circular permutations are n minus 1 factorial. Remember this formula, the number of circular permutations of n minus 1 factorial. Where in garland and beads of chain, garland or beads of chain, pula danda, pusala danda. Okay, where in garland or beads of chain, in this condition, the number of circular permutations are n minus 1 factorial by 2. It appears only one direction, not double direction. Therefore, the number of circular permutations in garland and beads of chain or formula is n minus 1 factorial by 2. Okay, a circular permutation n minus 1 factorial, whether in garland or beads of chain, the number of circular permutations are n minus 1 factorial by 2. That is the basic concept of permutation. And later combination. Combination, the direct formula NCR. NCR is equal. What is the difference between permutation and combination? Permutation means only arrangement. We just take all things and arrange in a row or arrange in a circular form, that is said to be permutation. Come to combination, we are just selecting the object. That is the difference between permutation and combination. Okay, in permutation, we are selecting and arranging. For example, the classroom. The classroom is said to be selecting the student and arranging in a row. That is said to be permutation. Come to combination, only selection. For example, on ground cricket selections are going on. That is said to be selection. The number of selections of n things taken out at a time is equal, or formula in combination NCR, where NCR is equal to n factorial by n minus r factorial into r factorial, standard condition. Okay, NCR is equal to n factorial by n minus r factorial into r factorial. Here, for example, I am taking one 8C3. The value of 8C3, 8 factorial by 8 minus 3 factorial into 3 factorial. Okay, write down this 8 factorial as 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 up to 1. But here in denominator we have 8 minus 3 factorial. 8 minus 3 is equal to 5 factorial. This one 5 factorial. Remaining 3 factorial, 3 into 2 into 1. This 5 factorial, both are cancelled. Okay. And remaining 8 into 7 into 6 by denominator 3 into 2 into 1. The value of 8C3. Observe here, a 3 is there. Numerator 3 values, denominator 3 values. 8C3, 8 into 7 into 6 by 3 into 2 into 1, 3 to 6, cancel 8 minus 56. Like that you do the calculation. Okay. In NCR, in combination also we have one formula. NCR plus NCR minus 1 is equal to n plus n minus 1 CR nana. A formula chudandi. First one, NCR is equal to n factorial by n minus r factorial into r factorial. And second one, NCR plus NCR minus 1 is equal to n plus 1 CR. And third one, NCR is equal to NCS. It's very, very important. NCR is equal to NCS. It implies either R is equal to S or N is equal to R plus S. Either R is equal to S or N is equal to R plus S. And finally, already you may did this in binomial theorem. NCR by NCR minus 1 is equal to N minus R plus 1 by R. N minus R plus 1 by R. Write down all this. And first one permutation and second one combination. Permutation means only arrangement. And most of the times while solving that probability and that numerator we have nana probability of anything, probability of P of A is equal to favorable cases by total cases. In this we get that favorable cases most of the times permutation. Sometimes rare condition we have like this also. Okay. And next one is probability. In this probability, the first one is random experiment. What is random experiment? Can anybody? What is random experiment? For example, I have a coin. And listen carefully. What is a random experiment? I have a coin. I'm spinning this coin. And what will happen, Nana? Definitely that will be head or that will be tail. Any one of these two. Either it may be head or tail. Everyone know. Everyone know the real, actual result. Everyone know that will be head or tail. But we know the actual result after the happening of the event. Okay. When coin in my hand, no one can know. After spinning of this one only, we can say that is head and that is tail. That is said to be random experiment. An experiment which the result is no, which the result is no without happening, before happening of the event. Okay. Right. 1 second. A repeatable experiment. This first one is random experiment. A repeatable experiment. A repeatable experiment. The result we know in advance. We know in advance. We know in advance. But actual result is known. We know in advance, but actual result is known after the happening of the event. Happening of the event is said to be, and this one is said to be random experiment. And this one is said to be random experiment. A repeatable experiment, the result we know in advance. Okay, before tossing the coin, we know that may be head or that may be tail. Coin weight and kanna munde manaku telustundamma. Adi head or tail edo compulsory padutundi. But we don't know the actual yet. That will be now after the happening. After I spin the coin, later on that may be on side or that may be on my hand. At that time we can say after removing the off hand, that is head and that is tail. And that one is said to be random experiment. Okay. Example is tossing a coin. Tossing a coin or spinning a die. Any one of these two. Tossing a coin or spinning a die, like that. And next one is trial and outcomes. What is trial? And second definition is trial and outcomes. What is trial? What is trial? Conducting or performing the experiment. This type of conducting. I am conducting tossing a coin. I am conducting this game. I am conducting throwing a die. And these type of events are said to be trial. Conducting or performing any one of these two. Conducting or performing the experiment. The experiment is said to be trial. Conducting or performing the experiment is said to be trial. And the possible results means that may be head, that may be tail, and that are said to be outcomes. The possible results are said to be, and this one is said to be what, Nana? Outcomes. The possible results are said to be outcomes. Same example, tossing a coin. Tossing a coin. And this one is example of trial. Throwing a die. Whatever it means, that is example of trial. And outcomes. Here the outcomes is what, Nana? Outcomes. What are the outcomes? When you throw a coin, that is said to be outcomes. Okay? Write down one. Tossing a coin is said to be trial, and head comma tail. These type of outcomes, these type of results are said to be outcomes. And sample space. Next one is sample point and sample space. Sample point and sample space. What are sample points? What are sample points? In a random experiment, the outcomes are said to be sample points. For example, here head, comma, tail, and these one are said to be sample points. The set of all sample points are said to be sample space. For example, the outcome, simply I am writing, Nana. The outcomes in a random experiment. In a random experiment are said to be sample points. Sample points and set of all sample points. Set of all sample points are said to be, are called simply, are called sample space. Are called sample space. Here we take another example. Let's throw a die. Let's throw a die. When a die is thrown, what are the outcomes, Nana? When a die is thrown, what are the outcomes? Throwing a die. What are the outcomes? 1, 2, 3, 4, 5, 6. All these are said to be outcomes. Die has 6 faces. 1, 2, 3, 4, 5, 6. You remember this thing? They may change the face of die also. Generally 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dot. Okay? Right. Here sample space S is equals 1, 2, 3, 4, 5, 6. Sample space denoted by, and this one, sample space denoted by, yes. Sample space denoted by, yes. When 2 dice are thrown, how many sample space exist? And one more example, this one is, next one. When 2 dice are thrown, when 2 dice are thrown, and this condition, how many outcomes? When 2 dice, 1 die means head and tail. When 2 dice are thrown, head, head, tail, head, tail. And this one is said to be sample space in this condition. Okay. And next one is simple event and elementary event. What is simple event? What is simple event? Simple event or elementary event. Simple event or elementary event. Sample space contains head, head, tail, head, tail, tail. Here, when 2 dice are thrown. When only 1 die is thrown, sample space S is equal 1, 2, 3, 4, 5, 6. When coin is tossed, sample space contains H, T. Only H, T. Only one sample point. Similarly, the sample event contains only one sample point. Only one sample bias. Simply read. Simple event or elementary event means it contains only one simple event. For example, a coin is tossed. A coin is tossed. Getting head. Example. A coin is tossed, getting head. And that one is simple event. When two coins is tossed, when two coins are tossed, you can observe the condition. When two coins are tossed, and this case is very, very important. When two coins are tossed, getting two heads, is simple point. Getting two heads is simple point, that is head comma head. That is also simple point. When two coins is tossed, getting only one head, that is not simple point. Listen this time. Continuation of this one. When two coins are tossed, getting one head is not a simple event or elementary event. Is not a simple event or elementary event. What is the difference between this example 2 and example 3? And observe here, example 1, first of all, a coin is tossed getting head. Only one event, simple event. Getting head or getting tail, that will be simple event. Okay? The simple event or elementary event contains only one sample point. And second one, two coins are tossed. Getting two heads. Getting two heads also only one condition. And that is H comma H. And here also that is simple point. And come to here. When two coins are tossed. Getting one head is not a simple event. Why? Why, sir? Getting only one head means like this. Head comma tail. And second one is tail comma head. And third one is head comma head. We can take all these cases. In simple event, we can't split. We take only one case. But here, head comma tail, tail comma head comma head. We can't split. Okay? That is the reason when two coins are tossed, getting one head is not simple event. And then what are they? Is head comma tail comma head comma head. And these are said to be compound events or mixed events. Okay, now write down. Next one is mixed events. That is the combination of two or more events. Two or more events is said to be mixed events. The combination of two or more are said to be mixed events. Example, Nana. You may write either example. When two coins are tossed, getting at least one head or getting at least one tail, all these are examples of mixed events. And next one is favorable cases. And the next one is what is very, very important, that is mutually exclusive events and exact events and later equally likely. All these are very basic. I think you may know. And next one is favorable cases. Favorable cases. In an experiment, that may be random. In an experiment, let capital AB an event, and this one is an event which is subset of sample space, which is subset of sample space. Subset with part of the set. For example, when a die is thrown, sample space S is equal 1, 2, 3, 4, 5, 6. In this capital A is equal to maybe 1, maybe 2, maybe 3, maybe 1, 2, 3, maybe 2, 3, 4, maybe 1, 3, 5, like that. If capital A is subset of sample space, yes, then A is said to be, favorable case or favorable cases. You take only one case, means write down that is case, no problem at all. Next three are very, very important, and mutually exclusive events and exhaustive, and last one is equally likely. And next one, mutually exclusive events. Okay. First, you try to understand the definition. What is exclusive? Exclusive means, okay, when we are going to a shop, there we have that exclusive menswear, exclusive kids wear. Okay, exclusive means only for that. Here also same thing. For example, here we have two elements, capital A, B. I mean two events. Intersection of these two. A intersection B is equal to pi. The intersection B is equal to pi. For example, this one menswear and this one kids wear. Intersection of this one, nothing. Therefore, A intersection B is equal to pi. Then these two sets A, B are said to be a mutually exclusive event. That means the event first one is prevent the happening of the remaining. The event first one. The first event prevents the happening of the next events, consecutive events. Next events, then that events are said to be, and this one are said to be mutually exclusive events. Okay, student, that is mutually exclusive events. Example, write down. Let capital A, B are two events. Okay, to take one example. When a coin is, when a die, you take die, better to take. When a die is thrown. Okay, your sample space S is equal 1, 2, 3, 4, 5, 6. And capital A is equal to, I am taking only odd numbers 1, 3, 5. And B is equal to even numbers 2, 4, 6. Observe the condition. A intersection B is equal to common of these two. A intersection B is equal to nothing, 5. Null set. The probability of null set is equal to 0. Okay, then A intersection B is equal to 5. And these type of events are said to be mutually exclusive events. Okay, and for this reverse of that exhaustive. Exhaustive means combination of all these. For example, shopping mall. Shopping mall means kids wear, men's wear. Like that, we have all things. That is said to be exhaustive cases. Exhaustive events. Okay, I am taking let A1, A2, so on, AN are events in a sample space, yes, All these are events in a sample space, yes. Then, union of all this. A1 union, A2 union, A3 union, so on, union, N is equal to S. Union of all these equal to S. Then, A1, A2, A3, so on, N are said to be exhaustive events. Then, A1, A2, A3, so on, AN are said to be exhaustive. Exhaustive events. Combination of these two, A union B is equal to what? Here A is equal to 135, B is the same example, but you take union. A is equal to 135 odd numbers and B is equal to 246 even numbers. Union of these two. What we get now? I can say 1, 2, 3, 4, 5, 6, which is equal to sample space. Then A comma B are. In this case, A comma B are. Why we are taking union? A comma B are exhaustive events. Here A intersection B is equal to 5. Where A comma B are mutual exclusive events. Because A intersection B is equal to 5. But you make union, the two is equal to combination of the two, union of the two. Union of the two is equal to sample space. Therefore, A comma B are mutually exclusive and mutually exhaustive. Both conditions are satisfied here. Okay, observe the logic. Here intersection, there union. And next one is equally likely. Very simple. Equal chance of occurrence. Equally likely means equal chance of occurrence. Equally likely events. Equal chance of occurrence. Equal chance of occurrence. Same example I am taking. Capital A is equal to here 3 events. Capital A is equal to, before that, sample space S is equal to 1, 2, 3, 4, 5, 6. When a die is thrown, and capital A is equal, I'm taking A is equal to 1, 3, 5. There are 3 cases. And B is equal to 2, 3, 6. And C is equal to, here 1, 3, 5 covered, 2, 3, 6 covered. What is not covered on here? 4. Okay, therefore I'm taking 1, 4, 5. 1, 4, 5. Here 1, 3, 5. 3 events. Here 2, 3, 6, 3. Here 1, 4, 5. Equal chance of occurrence of the events are said to be equally likely events. Okay. Next, the important definition and main definition of probability and latest sums. Probability, that is classification, definition of probability. Student, you directly write down probability. Only one thing, P of A or P of E is equal. Simple thing, probability of A is equal favorable cases by total cases. That's enough. Favorable cases by total cases. Favorable cases by total outcomes. Total number of outcomes. For example, when a die is thrown or when a coin is tossed, probability of getting head, probability of getting tail. Very simple example I am explaining here. When a die, we take coin. When a coin is tossed, the probability of getting head. Getting head. When a coin is tossed, how many events, how many outcomes are occurred, first of all? And that will be total number of outcomes. How many outcomes are occurred? That will be total number of outcomes. And next one, what is our probability? We have to find the probability of getting head. How many heads are occurred? Okay, that is for sample space contains total set of all sample points, which is equal to head comma head. Therefore, S is equal to events means write down this one, N of S is equal to 2. And getting probability of getting head, how many events? And only one event, head. Therefore, N of A is equal to 1. Then probability of A getting head is equal to our formula, N of A by N of S, which is equal to 1 by 2. Here the formula is for favorable cases by total cases. The favorable cases are N of A. N of A by N of S. Sometimes this can be written as N of E by N of S. Here P of A is equal to N of A by N of X. Some textbooks or my exam, they may given P of E, and P of E is equal to N of E by N of S. Any one of these two. P of A is equal to N of A by N of S, and P of E is equal to N of E by N of S. Favorable cases by total cases. In this we have complement, that is probability of A plus probability of A complement is equal to 1. You remember this thing. Favorable cases by total cases. Required cases by total cases. How many favorable? We have to learn the question properly. In this question, probability of getting head, only one case, that's why. 1 by 2. And next one, complement. Complement means, everyone know? Explain through a Venn diagram, very simple. For example, this is mu, we are taking generally, and this one is equal to A. And remaining this for total part will become so complement. Here also same thing, complement of A. Complement event, you simply write down that is complement event. Let capital A be the event in sample space, yes. Sample space, yes. Then complement of E denoted by. Then complement of capital A is denoted by. This one is denoted by A dash, like this, A bar, or they may return like this, A complement. Why use this one? Already we know P of A. Then we have one formula here, very, very important formula. This one, probability of A is equal, probability of A plus probability of A complement is equal to 1. Already we know probability of getting head is equal to 1 by 2, and getting tail is equal to 1 minus 1 by 2. Probability of A plus probability of A complement is equal to 1 by 2. Already we read one example, and there we get probability of A is equal to 1 by 2. Probability of head is equal to 1 by 2. And probability of tail, only one thing remaining. Therefore, probability of tail is equal to, of course, that is also 1 by 2. We can write directly by using this formula. Probability of A is equal to, I am writing 1 minus probability of A complement, or probability of A complement is equal to 1 minus probability of A. With this, 1 minus that is equal to 1 minus 1 by 2, which is equal to 1 by 2. And one more note, probability of A plus probability of A complement is equal to 1. The same way, the probability lies between the values 0, 1. And one more note, students. 0 less than or equal to probability of A, which less than or equal to 1. That means probability lies between the values P of A belongs to the closed interval 0, 1. 1 exists. Always your answer is lies between 0, okay? When 0 is actual, then probability of impossible event. And probability of impossible event is equal to 0. Okay? Right? Sums lo vellamandi. Here you take sums, Nana. Sums means first one leap year quotient and non-leap year quotient, and coins quotient, dice quotient, year sums, next playing cards, horses quotient, winning times. These type of sums we have. We begin with year sum. Find the probability that a non-leap year will have 52 Sundays. Okay. Find the probability that a probability that a non-leap year contains 53 Sundays. Try to understand the meaning now. A non-leap year contains 53 Sundays. Try to understand the condition. What is non-leap year? Non-leap year contains how many days first of all, and how many weeks? In this, how many 53 Sundays occur? That is the question. First of all, non-leap year, it contains how many days? Non-leap year contains 365 days. And how many weeks? How many weeks means you just divide with 7. Here we can write this 365 days as 7 into 52 plus 1. Sir, why 1, sir? 7 2 are 14 and 7 5 are 35 plus 1 36. 364 plus 1. That is 365 days. Observe the condition. Try to understand the condition. Why I multiply with 7 means 7 week contains 7 days. What is our question? Find the probability that a non-leap year contains 53 Sundays. Every week contains weekdays means Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. In every week we have every day. I mean 1 Sunday, 1 Monday, 1 Tuesday, 1 Thursday, like that. Like that, a non-leap year contains 52 days, 52 weeks. Additionally, we have one. Observe this condition. In these 52 weeks, we get 52 Sundays. Damn sure. Whatever it may be, begin with January 1st. January 1st may be Sunday, maybe Monday, maybe Tuesday, whatever it may be. We should get 52 weeks, which begin with the January 1st day. Definitely we have 52 Sundays, no doubt at all in this matter. Observe here, you check it. In these 52 weeks, definitely we have 52 Sundays. Okay, na? In these 52 weeks, here we have 52 Sundays, no matter in this. Whatever that first. For example, that 30, whatever that first. I mean 31st, whatever the 31st. A 31st day out, that extra day out. Okay, na? And this one, we have to know what will happen. Maybe Sunday, maybe Monday, maybe Tuesday, maybe Thursday, maybe Friday, maybe Saturday. Depends on December 30. For example, December 30 Sunday, next 31st Monday. December 30 Monday, 31st Tuesday. December 30 Tuesday, Wednesday. December 31st Wednesday, 30 Thursday. December 30 Thursday, 31st Friday. December 31st Friday, 31st Saturday. December 31st Saturday, 31st Sunday. Like that. I mean, this one day may be sample space. That one day may be maybe Sunday, maybe Monday, maybe Tuesday, maybe Wednesday, maybe Thursday, maybe Friday, maybe Saturday. Any one of these 6. 1, 2, 3, 4, 5, 6, 7. Any one of these 7. Sorry, not 6. Week contains.
Thank you.
Okay, power ochindana. Can I repeat this question? Some students may be outside of the classroom. Right. And observe here. A non-leap year. Non-leap year means it contains 365 days. Therefore, 7 into 52 weeks plus 1 day extra. In these 52 weeks, we should get 52 Sundays. That one day may be Sunday, Monday, Tuesday, any one of these 7 days. Okay, that's why sample space contains these 7. Here, write down that N of S is equal 7. Favorable cases, the probability that a non-leap year contains 53 Sundays, that is equal to N of A, which is equal to 1. Therefore, P of A is equal to your answer, N of A by N of S, that is equal to 1 by 7. 1 by 7. One student answer for that leap year, very good. For that leap year, how many 53 Sundays? In this, we have two options. Leap year contains 366 days. The same question you change here, Nana. Leap year. Leap year. Non-leap year will become leap year. In this condition, sample space will be changed. S is equal to Y star. In leap year contains 364 days. 366 means, 366 means that is 7 into 52 plus 2 days extra. In these 52 weeks, we get 52 Sundays, no doubt at all. But additionally, we have 53 Sundays. Therefore, these 2 days, sample space changes as, observe here, I am writing only one letter. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And Saturday, Sunday. 1, 2, 3, 4, 5, 6, 7. Again, 7 options. Therefore, N of S is equal to 7. And observe here, 53 Sundays. Here, Sunday, Monday. Here, Saturday, Sunday. Sunday, Monday, Saturday, Sunday. Therefore, your answer N of A is equal to 2. And finally, your answer P of A is equal to 2 by 7. 2 by 7. One student asked one doubt. How many Sunday, Mondays exist? How many Sunday, Mondays means? Sunday, Mondays means only one option. In that leap year, remember this question. In that leap year, both adjacent days are occurred means only one chance. Your answer is always 1 by 7. That may be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Anyone, your answer is 1 by 7. Right, students, one more question. A fair coin is tossed once. A fair coin is tossed. If a 4 pair, if 4 pairs, that is not A, Nana. If 4 pair coins are tossed once, not single coin, then find the probability of, getting 2 heads and 2 tails. Getting 2 heads and 2 tails. First, you discuss about N of S and later condition. What is N of S here? If 4 pair coins are tossed, then N of S is equal. Anybody? N of S is equal. When 1 coin is tossed, N of S is equal to 2 power 1. 2 coins, 2 squares. 3 coins, 2 cubes. 4 coins, N of S is equal to 2 power 4, that is equal to 16. N of S is equal to 16. And what is our question? Find the probability of getting 2 heads and 2 tails. Getting 2 heads and 2 tails. And observe here 4 coins. 1, 2, 3, 4. Okay, na? Getting first one head and second one head and remaining tail. And these cases. Okay, we have 4 phases now after spinning the coin. After happening of the event, we have 4 results. 1, 2, 3, 4. In this 2 fixed, you be fixed any 2. For example, that N of A will become 4C2. Okay, you take any 2 into remaining 2C2. Remaining 2C2 means no need to write down, that is 2C2 value 1. Okay, 4C2 which is equal 4 into 3 by 2 into 1. 2C2. 2 2 ja 2 3 ja 6. N of A is equal 6. Therefore, P of A is equal N of A by N of X is 6 by 16. And 2 3 ja 2 8. Your answer 3 by 8. Okay, na? Here we can create one formula. Okay, na? Out of n coins are tossed. For example, there exist R heads. Therefore, the probability of getting R heads is equal to P of A is equal to our formula NCR by 2 power n. NCR by 2 power. We can create this formula actually. Okay, na? When 4C2, in place of 4C2, we have NCR, and next one remaining that may be N minus R, CR means that is equal to 1. You directly write down NCR by 2 power n. Right, student? One more question. 2 dice are rolled. What is the probability that none of the dice shows number 2? 2 dice are rolled. What is the probability? Dice question. What is the probability that none of the dice shows the number 2? Shows the number 2. When 2 dice are thrown, what is sample space? When 2 dice are thrown, what is sample space? When 1 die is thrown, sample space S is equal 1, 2, 3, 4, 5, 6. When 1 die, you take only 1 die sample space this. When 2 dice are thrown, what is sample space? Anybody? S is equal. Okay, na? I have 1 die, you have 1 die. You both throw the dice. And what will happen? First one, 1, 1. I got 1, you got 1. One option, 1, 1. And next one, 1, 2. I got 1, you got 2. And next one, 1, 3, 1, 4, 1, 5, 1, 6, like that. Up to here only, Nana. Don't write 1, 7 because die has only 6 spaces. And next one, 2, 1, 2, 2, 2, 3, so on. Like that, the last one is next one, 2, 1, Nana. I'm writing all here, 2, 6. So on. Last one will become 6, 6. Why? 1, 1, 1, 2, 1, 3, 1, 4, up to 1, 6. 2, 1, up to 2, 6. I mean 2, 2, so on. 3, 1, 3, 2, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, so on. 4, 6. Again, begin with 5, 1, begin with 6, 6, 1, so on. Last one is 6, 6. Okay, na? First one 6, second one 6, therefore 6 into 6. I mean we have 6 rows and 6 columns. N of S is equal, sample space S contains 6 into 6, which is equal 6 square, that is 36. When 2 dice are thrown, 36. 3 dice, 6 into 6 into 6. Then what is our question, Nana? What is the probability that none of the dice shows the number 2? Here observe the question. They may create in place of 2, 1, in place of 3, 2, 3, 4, 5, 6. None of the dice shows the number. none of the dice shows the number means you just remove 11 items. Why? Because in 2 serial we have 6. Remaining 2 occurs in 5 times. 2 plus 6, 5. Therefore, n of a is equal. N of a is equal. Remember this condition, 6 plus 5 is equal 11. Sir, why you are writing 6 means 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And 2 occurs in first row 1 time. Third row already completed. Second row completed, sorry. Third row, fourth row, fifth row, sixth row. 5 times. 5 plus 6, 11. N of a is equal. Here they may kept 2 or 1 or 4 or 5 or 6. The 2 dice are rolled. What is the probability that none of the dice shows the number 2, shows the number 1, 3, 4, 5, 6? And this is the condition. Okay? And P of A is equal to 11 by 36. They ask, there is Garama complement, sorry. Probability of A complement is equal to 1 minus P of A, which is equal to 1 minus 11 by 36. Okay, therefore P of A is equal to LCM 36, 36 minus 11, and P of A is equal to 25 by 36. I think your doubt clarified, sharp person. Contains 2 is equal 11 by 36. Does not contains means A complement. That's why I took A complement. A complement is equal 1 minus P of A. 1 minus P of A is equal 11 by 36. Okay. Right. Already I said 11 events. Total 36. 36 minus 11. 25. 25 by 36. That's it. And one more question. When 2 cards are drawn from a pack of 52 cards and random, find the probability of getting both club cards. When 2 cards are drawn. When 2 cards are drawn from pack of 52 cards. From pack of 52 cards. At random, of course, randomly. Everything is randomly. Find the probability of getting. Find the probability of getting both club cards. Both club cards. You know the classification of playing cards? Playing cards contains how many in total? 52. In this we have, in these 52 cards, we have 2 parts. First of all, 26 red and 26 black. Black or blue, Nana, depends on that condition. Here also we have 2 parts and 13 14, 13 diamond, 13 club and 13 spade. Okay, that is said to be classification of playing cards. In this we have face cards and like that number cards, a different matter. When 2 cards are drawn from a pack of 52 cards, when 2 cards are drawn, therefore n of s is equal to out of 52. They clearly mentioned. Okay, therefore n of s is equal, your answer 52C2. Just you take only 2 cards. Next, find the probability of getting both our club cards. Observe here. Here we have diamond 13, 14, dime 13, spade and club, the 2 also 13, 13, 13. Okay, Nana? Find the probability of getting both our club cards. Both are club cards means n of a. You should take the 2 cards from that club only. Therefore, n of a is equal to 13C2. N of a is equal to 13C2. Therefore, P of a is equal to our answer. N of a by n of s is equal to 13C2 by 52C2. Yes, C2 students. N of a is equal to 13C2 by 52 C2. Make the calculation. That is 13 into 12 by 52 into 51. You just do the calculation. Your answer is 1 by 70. 13 4 ja and 4 3 ja 12. Same, they may change the word. In place of club, write down, they may written diamond or spade like that. Art. Art means. And one more question. A class has 15 boys and 5 girls. Suppose 3 students are selected random from the class. Find the probability that they are all boys. Find the probability that they are all boys. Again, same model question, 6th one. A class has 15 boys and 5 girls. 15 boys and 5 girls. Suppose 3 students are selected. 3 students are selected at random. Randomly, I am selecting 3 students. Random from class. I mean from the class. Find the probability that they are all boys. Find the probability that they are all boys. Can anybody? They are all boys. N of S is equal. N of S is equal to what? First year. N of S is equal to, how you take N of S? Here, how many boys, Nana? Given that there are 15 boys and 5 girls. 15 boys and 5 girls. N of S is equal, you should take 3% from these total students. Okay, N of S is equal, write down this 15 plus 5 C3. That is equal to 20 C3. And next one. 15 boys and 5 girls and 3 students. How many students are taken? And we are going to find the probability of taking 3 students out of these 20. 3 students are selected at random from the class. Therefore, N of A is equal from the class. Find the probability that they are boys. All boys kavali antunar. All boys kavali antunar. Then compulsory you take that 15 boys, that 3 boys out of these 15. Therefore, N of A is equal to your answer 15 C3. That is P of A is equal N of A by N of S is equal to 15 C3 by denominator 20 C3. Okay, write down. And one more case. Next question. Out of 30 consecutive integers, they may ask like this also. Out of 30 consecutive integers. Two integers are drawn. Two integers are taken. Okay. Randomly, of course, everything is randomly drawn. Find the probability that their sum is. Find the probability that their sum is. Their sum is. What is the first one? Sum will become an odd number. Sum is odd number, and second one, an even number. An even number. Sum is odd number and sum is even number. Can anybody? Okay. Out of 30 consecutive integers, 2 integers are drawn at randomly. Find the probability that their sum is an odd number first case and even number second case. How you take that one? N of s you directly write down. Here 30 consecutive integers. 2 integers are drawn. You directly write down N of s is equal. What is N of s? No. That N of s is equal 30C2. We are taking 2 integers. Therefore 30C2. And what is our question? Find the probability their sum is odd number and their sum is even number. How you take? Some odd number means how you take it? Out of these 30, how many we have even numbers and odd numbers? Okay, in this 30, we have 15 even numbers and 15 odd numbers. 15 even numbers and 15 odd numbers. Sum will be odd number means you take one even and one odd, because sum of 2 even numbers is always even. Sum of 2 odd numbers is always even. Observe the condition. Sum of 2 even numbers is even and sum of odd numbers is even. That's why you take one number from 15 even and another from odd. I mean you take one even number and odd number. Then only the sum will be odd number. Let capital A be even that sum will be odd number. Let capital A be even that sum will be odd number. Therefore, N of A is equal. You take one number from even, that is 15C1. And here observe the condition. We using the condition and. And means into nana. R means plus. And means into. R means plus. 15C1 into 15C1. One from even and one from odd. One from 15 even and one from 15 odd. Therefore, N of A is equal 15C1 into 15C1. Therefore, P of A is equal. P of A is equal N of A by N of S, which is equal to 15C1 into 15C1 by denominator 30C2. Calculation. 15 into 15 by 15C2 value. 15C2 value. 15 into 15 by 30C2 value. 30 into 29. By denominator 2 into 1 means that will be numerator into 2 into 1, like that. Okay, 15 2 ja 30. This 30 cancel. Your answer here. Here the answer, the probability of getting odd number when you take 2 numbers is equal 15 by 21. Next one, an even number. An even number means don't do the total calculation, that is probability of A complement. Okay, an even number means you take 2 numbers from 15 even and 2 numbers from 15 odd. Okay, na? This is first case, P of A. And second one, probability of getting even number. Probability of getting even number. Sum becomes even number. I am writing even. 1 second. Probability of getting, find the sum. Sum of 2 numbers is even is equal 1 minus probability of A complement 1 minus 15 by 29 LCM 29 minus 15, your answer 14 by 29. And observe here, Nana, probability of getting even number means you should take 2 numbers from even or you should take 2 numbers from odd. In this condition, N of A may be different. Here N of A is equal 15C1 into 15C1. One from odd number and one from even number. And but in this condition, the sum will be even number means you should take that, you take that N of B. N of B is equal 15C2 plus 15C2. 15C2 plus 16C2. Either the 2 are even or odd. Any one of these two. Either the 2 are even or odd. Okay, na? 15C2 plus 15C2 by N of S value 30C2. You just make this calculation and these two are equal. Okay, try to this one, that is simple method. Probability of getting odd number, one from even and one from odd, one from out of 15 and one from out of 15 odd, that is 15C1, 15C1. Your answer like this. 15C1 into 15C1 by 30C2. Some even number means 1 minus P of A. Like, I think this question is clarified. They may ask. Right. Next one. One algebraic condition question. If the number x is selected, if the number x is selected from natural numbers, begin with 1, 2, 3. Numbers 1 to 100, not 1, 2, 3. 1 to 100. Find the probability. Find the probability of, find the probability for the condition x plus 100 by x, which is greater than 29. X plus 100 by x greater than 29. If the number x is selected from the natural numbers 1 to 100. Therefore, n of a is equal to, we are writing that n of a is equal directly 1 to 100 means n of a is equal to 100 C1. Because sample space S contains what, Nana? 1, 2, 3, so on up to 100. And moreover, clearly mentioned that natural numbers means n of S is equal to your answer 100 C1, which is equal to 100. Clear in this. And x plus 100 by x greater than 29. X plus 100 by x greater than 29. Observe the condition. The required number satisfies the inequality x plus 100 by x greater than 29. Inequalities. How is it satisfied? Okay. Next one. X plus 100 by x which is greater than 29. Here LCM, students, x. I'm going to solve this inequality. X, and here x square plus 100 which is greater than 29. That x square plus 100 greater than 29 into x. Write down 29 left side and check what will happen. I am asking how many students have solved this inequality. X square plus 100x, minus 29x plus 100 which greater than 0. X square minus 29x plus 100 greater than 0. Factorization. Okay, 25 4 ja or 4 25 ja. Minus 4x minus 25x plus 100 greater than 0. Here x common, students. X minus 4 minus 25 common. Minus 25 common. X minus 4 greater than 0. Factorization. That is x minus 4 into x minus 25, which greater than 0. Can anybody? X minus alpha into x minus beta less than 0 under the condition alpha less than beta, which applicable on quadratic expression. While going to solve this type of equation, first you write down first value is smaller and second value is bigger. Always. Alpha less than beta. X minus alpha into x minus beta. Okay, na? And this one is satisfied when you take the values of x which is less than 4 and greater than 25. Functions also came. Okay, na? Quadratic. And this one is satisfied when x less than 4 and x greater than 25. When you take values more than 25, the expression is positive. 26, 27. One step. When you take x less than 4, the expression is positive. In between, the expression is negative. Any doubt, you take real line. Okay, now if you follow the real line, that will be satisfied, students. Here plus, here plus. Write down plus up for convenience. Here plus. In between these two, the expression is negative. Here negative. The curve moves like this. Okay, beyond that matter, just I am explaining. x minus alpha into x minus beta greater than 0 means x less than 4 and x greater than 25. Less than 4. Less than 4 means don't take that value minus infinity. Because they clearly mentioned that. That's why I took here underline. Natural numbers. Less than 4 means that x belongs to here only few elements, that is 1, 2, 3 only. More than 25. More than 25 means begin with 26. 26, 27, so on up to 100. Now check how many are exist. 26 to 100 here 75. Yes, 75. Here 3. Therefore, n of a is equal. Favorable cases are less than 4, 3 students, and more than 25, 75. Is equal to 78. Therefore, P of A is equal to our formula n of A by n of S, which is equal to 78 by 100. That is 0.78. 0.78. It's quadratic, and Vevi-Kadu theorem is applied on probability in that new natural number. Okay, right, none once. Next one question. On a festival day, a man plans to visit. A man plans to visit 4 holy temples. 4 holy temples. A, B, C, D. The temples names are like that: A, B, C, D in random order. Next, first one in this, find the probability that he is going to visit these temples under circumstances, some conditions, which is first condition, A before B. A before B. B ki vellalante compulsory A velli undali. And second one, A temple visit chestundali. I mean, A before B and B before C. Try to understand this question. A before B, first one, and second one, A before B and B before C. For example, once you read the question properly, on a festival day, for example, I am going to visit 4 holy temples. I am going to visit 4 temples. Nine temples kellam anukuntamma, 4 temples. They are A, B, C, D. Then find the probability that he visits A before B, and second one is A before B and B before C. How many temples they are given? 4 temples. These 4 temples can be visited by me. In how many ways, Nana? How many ways? Can anybody say what is N of S? In this we can know our permutations class, permutations concept. N of S. N of S is equal to 4 factorial. These 4 temples can be visited in 4 ways. I mean 4 factorial ways. Okay, 4 factorial, which is equal to how much? 24. Maybe first one, 4 options, Nana. A, B, C, D, 4 temples are there. First one, 4. Second one, 3. Second, next one, 2. And next one, 1. Like that. N of S is equal to 4. Arrangement. We are not going there in the temple. Okay. visiting the samples in arrangement order. Now, for example, there are 4 chairs. Okay, I explain very clearly here. Like this. I have 4 chairs here. When I enter into the room, then automatically I have how many options, Nana? 1, 2, 3, 4. For me, I have 4 options. The next person, for example, this first person, I have 4 options. Next person, for example, I sit here. Next person has how many options, Nana? 3 options. Second person. And third person, next one has only 2 options. And finally, last person has only 1 option. That is 4 into 3 into 2 into 1. First one has 4 options. Second one has 3 options. Third one has 2 options. And last one has 1 option. That is 4 into 3 into 2 into 1. That is 4 factorial. 4 factorial is equal to 24. The number of ways of visiting these 4 temples is equal to 4 factorial. And first condition, what is our first condition? A before B. A before B. And first one is what, Nana? A before B. మనం B కి వెళ్తున్నామంటే కంపల్సరీగా ఏ టెంపుల్ విజిట్ అయి ఉండాలి. That is the condition. A before B means there are 4 temples. Okay, na? Actually, diagram is wrong method, Nana, here. Diagram is not applicable. A before B means there are so many ways. If you write A, okay, you can write B here also, here also, here also, any one of these. Okay. If you write A, you can write B here, any one of these two. Okay. If you write A, B here, only one option. That's why we don't know. But we have fixed AB order is there. AB order is there. In between A comma B, we may insert CD temples. The condition A before B. A before B. I can visit like this also. A, C, B. That's my choice. I can visit like this also. Here A, C, here D and B. Like this also. That's why diagram is not correct. To understand this concept, just I wrote these 4 boxes. A before B. That means you just left that A comma B because that is fixed. Remaining what, Amma? Remaining C comma D. The C comma D can be arranged in 2 boxes. Can be arranged in 2 boxes out of these 4 in 4p2 ways. Therefore, N of A is equal to, on this condition, N of A is equal to 4p2. We are arranging. I am arranging my visiting in 4p2 ways because AB is fixed. A before B, whatever it may be. B ki veltunante compulsory A ki velli untaను. That is fixed. Therefore, remaining N of A is equal to 4p2. The value of 4p2, that is equal to 4 into 3, which is equal to 12. Therefore, P of A is equal to the probability of visiting the first condition, I mean A before B, the probability that he visits A before B is equal to P of A, N of A by N of S, which is equal to 12 by 24, that is equal to 1 by 2. Is equal to 1 by 2. And this is first case. And second case, what is our second case, Nana, here? A before B and B before C. Here only we have A before B and B before C. That means condition on ABC. We just left that remaining. Therefore, A, B, C are fixed means D is, we don't know. Okay? That D may be fixed in this 4 box only one way. Only one way. Maybe first place, maybe second place, maybe third place, maybe fourth place. Therefore, in this condition, I am taking this N of B. Okay, na? Already I take A, Nana, you take N of E for convenience. N of E is equal to 4P1. We take only one place for D. Therefore, N of E is equal to 4P1, which is equal to 4. Therefore, P of E is equal to N of E by N of S, that is equal to N of E value 4 by 4 factorial value 24. That is equal to 1 by 6. Our answer is 1 by 6. Try to understand this question now. Write down. That integers we have one question. Next. Observe here. Out of 30 consecutive integers, but different case here. Out of 30 consecutive integers, yes, consecutive. Integers. 3 integers are drawn, not 2. Before question we took 2. 3 integers are drawn. 3 integers are drawn. Find the probability that the product is. Find the probability that the product, not addition, and before we have addition, product is the first one, odd number and odd number. Product is an odd number. Second one is an even number. And even number. When you take 3 numbers, product will be odd number and product will be even number. How no? Once read everyone and try to do. N of S is equal out of 30 consecutive integers. Out of 30 consecutive integers, 3 integers are drawn. Therefore, N of S is equal, you directly write down N of S is equal to 30C3. Next, find the probability that the product will be an odd number first case and even number. How you take that N of A? In these 30 consecutive integers, we have 15 even and 15 odd. Product of 3 numbers will be odd number, means you have to take what? You have to take even numbers or odd numbers. One thing, everyone. One thing, everyone. N of S is equal to, you directly write down, that is 30C3. Again, same case. In the 30, we have how many, Nana? 15 even and 15 odd. Okay? Let capital A be the even, that product will be odd number. Product of 3 numbers is odd number. And how you take the 3 numbers? Capital B the event of taking 3 odd numbers from 15 even or 15 odd. Any doubt you check it now. Even numbers, even into even is even. Odd numbers, odd into odd. You take 1 into 3 into 5, like that. You should take the 3 odd numbers from 15 odd. Let capital A be the event of getting 3 odd out of 3 numbers out of, not 3 odd, 3 numbers out of 3, 15 odd. 15 odd numbers. Therefore, N of A is equal to 15C3. Therefore, P of A is equal to N of A 15C3 by denominator 30C3. Probability of getting 3 odd numbers is equal to 15C3 by 30C3. 3 even numbers means similar same condition. 1 minus. Okay, na? For this is answer. What I said, already I explained this condition. Probability of getting 3 even numbers, you take P of A is equal to 1 minus probability of A complement. You just do the calculation. 15 into 14 into 12 by 30 into 29 into 28. 15 into 14 into 13 by 3 into 2 into 1. Here 30 into 29 into 28 by 3 into 2 into the 2 are cancelled. Okay, students?
Sir.
Hello?
Sir.
Chepandamma.
2 even, 1 odd also even.
Okay, you can take like this also. It is better to take like this.
అంటే
1
ఆర్ అని
minus,
రాయదా
I'm
సార్?
saying. రాయకండి అమ్మా, అలా రాయకండి. R. వద్దమ్మా. 1 minus. Probability of A complement. 2 even and 1 odd. You can take that 15C2 into 15C1. ఇదే కదమ్మా మనం అడిగేది, ఈ కేసే కదమ్మా. అండ్ ఈవెన్ నెంబర్.
ఫస్ట్ ఈవెన్ ఆర్ ఈవెన్ కేస్.
Even cases kadamma, and that condition n of A is equal 15C2 into 15C1 by 30C3. And you are taking 3. Okay, when you 15C2 into 15C1 by 30C3. C3. R అనే కేసు మనకి ఇక్కడ సాటిస్ఫై అవుతూనే వస్తుందమ్మా. ఫర్ ఎగ్జాంపుల్ 15C2 సాటిస్ఫై అయింది అనుకోండి, ఆ కేసులో వస్తుంది. ఇంతకుముందు మనం చేసాం కదమ్మా. At that time 2 even numbers. Some will be even number, means you should take 2 evens and 2 odd. 15C2 దగ్గర అడ్జస్ట్ అవుతుంది, ఆన్సర్ వచ్చేసింది 15C2. ఆ కేసులో వస్తుంది, లేదా సెకండ్ కేసు 15C2 plus 15C2 by 30C2. Better to use complement condition. One more question. A bag contains simple questions everyone can do. 4 red, 5 black, 6 blue balls. 4 red, 5 black, 6 blue balls. Find the probability that 2 balls drawn. Find the probability that 2 balls drawn. 2 balls drawn at randomly. Of course, everything is at randomly. 2 balls drawn simultaneously from the bag. Are a red and a black. Are a red and a black. Underline the word and is given. Student, and is given. A bag contains 4 red, 5 black and 6 blue balls. Find the probability of drawing 2 balls. Find the probability that 2 balls drawn at random simultaneously from the bag are red and black. Any one of these two. From the bag, red or black ball. How many balls are taken? First of all, sample space contain 4 red and 5 black and 6 blue balls, all in one bag. Therefore, N of S is equal sample space 4 plus 5 plus 6. 4 plus 5 plus 6. C. We are taking 2 balls, means write down C2. Okay. 6 plus 4. 10 plus 5, that is equal to 15C2. N of S is equal, students, 15C2. Simple condition. Find the probability that 2 balls are drawn simultaneously at a time. Actually, we should write that condition at a time, because we have one more option, one after the another. Okay. Drawn simultaneously. Any doubt, write it clearly. Compulsory we use the word simultaneously, because one after the another, one option is there. That's why. Okay. Find the probability that 2 balls are drawn simultaneously from the bag are red and black. Very simple question. N of S is equal 15C2 and N of A is equal, how many red here, Nana? 4 red here. And how many black?
5 lakh.
5 lakh. 4 plus 5. Okay. Not 4 plus 5. We are taking 1 red and 1 black. Okay. Yes. You are right. Come again. Cheppamma.
4C1 into 5C1.
4C1 into 5C1.
4C1. Very good. 4C1 into 5C1. Therefore, right. N of A is equal to 4 into 5. And P of A is equal to 4 into 5 by
4 into 5 by
15C2.
15
15 into
that is 4
14.
into 5. Here 2 into 1. Denominator
15 into 14.
14. 2 1 ja, 2 7 ja, and 5 1 ja, 5 3 ja. 2 2 ja, and 2 7 ja. 4 by 21?
21.
21.
Very good. One after the other means, first you take the score ball. Okay, that is different condition using multiple theorem. Later we discuss. Multiplication theorem. One more question, student. A box contains 12 2-rupee coins. 12 2-rupee coins. And 7 1-rupee coins. 7 1-rupee coins. And next one, 4 half-rupee coins. 4 half-rupee coins. If 3 coins are selected, 3 coins are selected from this, find the probability that selected find the probability that. What is our first question here? 4 questions, Nana. I am explaining third one, fourth one. 1 and 2 are very easy. Selection contains at least 1 rupee coin. Later we discuss the first and second. Selection contains at least 1 rupee coin. At least 1 rupee coin. At least 1 rupee coin. Underline that one. And second one, all selected 3 coins have same value. All selected 3 coins. All selected 3 coins have the same value. Have the same value. Can anybody first? What is N of S? Total how many coins? 12 2-rupee coins, 7 1-rupee coin, and 4 half-rupee coins. A box contains 12 2-rupee coins, 7 1-rupee coin, and 4 half-rupee coins. If 3 coins are selected randomly, find the probability that selection contains at least 1 rupee coin. Selection contains at least 1 rupee coin. Rupee coin 1. And second one, all selected 3 coins have the same value. N of S is equal. Total how many? Students, N of S is equal 12 plus 7 plus 4. 19 plus 4 N of S, 23 C3. C3. Yes, next. Selection contains at least 1 rupee coin means at least 1 rupee coin. At least 1 rupee coin. Use that condition, 1 minus condition. Try to solve.
7C1.
Minus all containing.
7C1. 7C1 into 16C2.
At least 1 means you can take 7C2 also. That is also applicable. Okay. Using that complement condition. using that complement condition. For example, in a classroom, there are 50 strength. In this, boys are 20 means girls means how many? Boys are 20. Total 50 strength. Boys are 20. Girls how many?
1 minus 3 should be all
Yes.
other kinds.
1 minus. 1 minus?
All 3 kinds.
1 minus. 1 minus correct only, Nana. 1 minus?
7C.
1 minus other than that 1 rupee kind.
7C.
Other than that 1 rupee kind. 1 minus remaining. 12 plus 4. 1 minus 12 minus 4. 1 minus 12 minus, sorry, 12 plus 4. 12 plus 4, 16. 16 C3. I am taking kinds. Other than that 1 rupee kind. 1 minus. Therefore, P of A is equal. Actually, write down not like this. 1 second. The question is, selection contains at least 1 rupee kind. I am taking no 1 rupee kind. No 1 rupee 3 kinds. That is equal to 16 C3. Okay, Nama. In this no 1 rupee kind, I am taking the 12, the 3 kinds from this 12 plus 4. Okay. Since 12 plus 4 is equal to 16. To remember this one, I am writing 12 plus 6. Therefore, P of A is equal probability of selecting without 1 rupee kind. That is equal to N of A by N of S, which is equal to 16 C3 by 23 C3. Now A complement. A complement is what, Nana? Including that one. That is 1 minus P of A is equal to 1 minus 16 C3 by 23 C3. Okay, students. 1 minus 16 C3 by 23 C3. Here, we are taking no rupee kind. Yes. Can I ask one question? Sum of 3 kinds is maximum. How you take? Sum of 3 kinds is maximum. Sum of 3 kinds is maximum means you take the 3 kinds from this 12 to 2 rupee kinds. Your answer is 12 C3 by 23 C3. And sum of 3 kinds is minimum. Minimum means at that time you take the 3 kinds from that half rupee kinds, because half rupee kinds minimum value, 2 rupee kinds maximum value. And taking 3 kinds from different, take 3 kinds from the different value. Different value means one from 2 rupee, one from 1 rupee, one from half rupee. And that condition N of A is equal 12C1 into 7C1 into 4C1. Okay, na? And next one what, Nana? All selected 3 kinds have the same value. All selected 3 kinds have the same value means 12C3 plus
7C3 plus 4C3.
Yes, 12C3 plus 7C3 plus 4C3. Okay. And this condition is clarified, girl? No 1 rupee. Okay, Namma?
Okay, sir.
Right, remaining we'll see on next class.
Okay.
Sir, unnara?
Okay, sir. Thank you, sir. Thank you for informative session, sir. Very nice, sir. Nice presentation. Any more questions from your side, my dear students? Any questions from you?